Good evening to you. This is Miss DH for Chapter 11, Lesson 1, Simplifying Rational Expressions. Basically, we're going to encounter a lot of things we've talked about back in Chapter 8, which was factoring and special cases, and just some basic math, remembering that adding the opposite is the same as subtraction, and also that the commutative property of addition. All of those things are going to come into play, so I hope you remember, and if not, I will touch briefly on them. If you need help, you can always come talk to me. Alright, so an expression that can be written in the formula of polynomial over polynomial, basically a polynomial over a polynomial in a fractional form, is a rational expression, much like these examples. 1 over x plus 2 over x minus 3, and x squared minus 5 over x squared minus 10x plus 25. All of those are considered rational expressions because they are written as fraction. Alright, and just remember that domains cannot be 0 for this book. For the rest of this chapter, assume that any value that makes the denominator 0 is excluded from the domain. So if we were to talk about that, in this first example, x over 1, x couldn't be 0. The domain can't be 0. And for the second example, x cannot be 3, because if in the first example x was 0, that means the denominator would be 0, and that would be undefined, which we're not going to deal with in this book. And then in the second example, if x was 3, it would be 3 minus 3, which means the denominator would also be 0, which we're not going to deal with. So just assume that any value of x or whatever variable you're using in the denominator cannot make that denominator equal 0. Okay, so there you go. Cannot be 0. So let's move on. Alrighty. So remember, an expression is in simplest form when the numerator and denominator have no common factors. So this is going to be very important because you're going to have to factor some stuff out so that you can simplify it, and also so you can cancel things out so it's, again, simplified. So again, basically what you're doing is a lot of simplifying, but you're going to have to factor to do the simplification. Alright, so what is a common factor for 15 and 25? Well, that would be 5, and I could write 15 times b as 3 times 5 times b, and I could write 25b squared as 5 times 5 times b, and then cancel out what's the same on the top and the bottom. 5 over 5 is 1, b over b is 1, and that leaves me with 3 over 5b. Pretty cool, huh? Alright, next one. We have 12c squared over 3c plus 6. So the moment that you have an addition or subtraction problem, basically you have a polynomial, right? You're going to have to do some factoring, figure out what you can pull out so that you can simplify the rational expression. Alright, so I can write 12c squared as 3 times 4 times c, or just 3 times 4 times c squared. And I can pull a 3 out of 3c to the 6th. So if I pull a 3 out of 3c to the 6th, I'm left with 3 times the quantity, c plus 2. And you could also check that by distributing. Distribute the 3 to the c and the 2, and you get the original problem. So let's figure out what we can cancel out. In this case, it's only one thing. It's just the 3. And we're left with 4c to the 2nd over c plus 2. And that's it for that one. Alright, next example. We have 4m minus 2 over 2m minus 1. I'm going to go ahead and factor the top part, the numerator, and I get that. And guess what? Just because I have a polynomial over a polynomial, as long as they're the same, I can still cancel them out. So that 2m minus 1 on the top will cancel out that 2m minus 1 on the bottom, leaving me just 2. That's how simple some of these problems are. They're kind of exciting with how simple they are, and you're just kind of getting them so that you can cancel out as much as you can. That's it. Alright, we got another one. We have 20 plus 4t and t plus 5. Well, I'm going to pull out a 4 in that top numerator, and that's going to leave me with 4 times the quantity, 5 plus t. And now notice how I changed that up here. Notice how they look different, but are they really different? No, I used the commutative property of addition. Since they're being added, I can actually switch the locations, commute, change, move, and change the location, and it's not going to change anything. So now that I have 5 plus t over 5 plus t, I can cancel them out. So again, commutative property of addition in work. Make sure you pay attention to that, because at first it might not look like it, but if you use that simple little trick that you probably learned back in 4th or 5th grade, and at least in 6th grade, you're going to get it figured out and be able to cancel stuff out and get your final answer 4. Alright, next we need to talk about factoring quadratic expressions inside of irrational expressions. Hopefully you remember how to do this. Make sure you pay attention to special cases to help you factor quicker, and make sure you factor out stuff. Alright, so let's go ahead and factor out that numerator. We can pull an 8 out, and that's going to leave us with 8 times the quantity, 8 plus 2. And for the bottom part, there's nothing I can factor out, so I'm going to just have to, use my table, and it's not a special case either. So I'm going to go ahead and do that, and I'm going to get right here. Works out. Now, this is Chapter 8 material, so I'm not going to spend a lot of time on it, but I do need to remind you to check your FOIL. You need to make sure your FOIL works out. Alright, so if I went ahead and FOIL this, 2a times a equals 2a squared. 2a times 1 is 2a. 2 times a is 2a. Does not end up working out? It doesn't end up working out. Dumb, Miss Deech, you planned it like this. So, if you don't make sure that your FOIL works out, you're going to have a problem. First, nothing will cancel out to simplify. Notice how I don't have an a plus 2 on the bottom to cancel out that a plus 2 on the top. And that's kind of what we're looking for. Now, it's not always going to happen even if you FOIL correctly, but it's something that can be a red flag. And second, obviously, is if you FOIL my current denominator, you're not going to get the denominator in the original problem. So there is your other problem. So let's go ahead and fix this. There we go. Now if I FOIL, it's going to be correct, and I can cancel out. I have an a plus 2 on the top and an a plus 2 on the bottom, which allows me to simplify. Beautiful. Check that out. So you do need to make sure that you FOIL correctly, because if you don't FOIL correctly, you're probably going to miss out on this really key simplifying part, which is canceling out similar things that are on the top and the bottom, your numerators and denominators. Alright, number 2, we have c squared minus c minus 6 over c squared plus 5c plus 6. So let's go ahead and factor this. There we go. There's the numerator, and then factor the denominator. There you go. And guess what we can cancel out? C plus 2, which leaves me c minus 3 on top and c plus 3 on the bottom. And that's as simplified as it gets. Alright, we have at least one more special thing to talk about, and that is opposites. And just remember FOIL. Okay, so opposites. The numerator-denominator combo below, in this example, x minus 4 over x, x minus 4 over 4 minus x are opposites, which means that you can factor out a negative 1 from either the denominator or the numerator or denominator, to allow you to simplify the rational expression. So let's check this out. So again, we're going to use two concepts here. We're going to use adding the opposite and the commutative property of addition to show that after I factor out a negative 1, I am then able to cancel some stuff out. Okay, so I've got the top, and I'm going to factor a negative 1 out of the bottom. So if I pull a negative 1 out of the denominator, I'm going to get negative 1 times negative 4 plus x. Okay, and you can FOIL that to see how I get back to my original problem. Or not FOIL, excuse me, distribute. So now that I have an addition problem inside those parentheses in the denominator, I can use the commutative property of addition to switch the location. And then when you have x plus negative 4, that's the same as x minus 4. Some basic math right here. But now that I have x minus 4 as a denominator and x minus 4 as a numerator, I can cancel them out, leaving me just 1 over negative 1. Now remember, if you completely can cancel out an entire numerator, you have to leave a 1 there. Now if you can cancel out an entire denominator, you just leave it as 1, and then you can get rid of the fraction bar and the 1 as a denominator. But since I was able to cancel out the entire numerator, I have to leave it as 1. But 1 over negative 1 is just negative 1. Pretty cool, huh? So that's how you divide opposites. That's how you take care of that. Now there's going to be obviously more complex problems than that, but let's go ahead and take a look at one. Now this is also a special case. m to the second minus 64 is a special case. It's a difference of squares, so make sure that you take care of that. So a difference of squares is just m plus 8 times m minus 8, but I went ahead and added the opposite for you so that you can see it. Okay, so I'm going to go ahead and take the m plus negative 8, because that's actually my opposite, because this is the one that could be written like this. Okay, but then by adding the opposite, I've got it. So this was the opposite. This is how I'm going to write it so that I can take care of my negative 1 that I need to factor out. So, special case, and add the opposite. Right there. Alright, so now let's go ahead and pull out a negative 1 so that I can do the opposite. And there we go. I can cancel those things out right there, and I'm left with my answer, which is 1 over negative 1 times m to the 8, or m plus 8, which is just negative 1 over m plus 8. Okay, so this step might confuse you guys a little bit, but just go through it slow. Remember adding the opposite, remember factoring and all of those other steps, and just go through it slow. Okay, so number 3, I'm going to just do these steps without talking about it, because really it's actually a lot simpler than it looks. Add the opposite and then factor out a negative 1, and then you'll actually have something that you can cancel out once you use a commutative property of addition, and then you're just left with negative 2 over 3, which is pretty easy. Alright, bread. Evaluating rational expressions. The baking time for bread depends in part on its size and shape. A good approximate for baking time in minutes of a cylindrical loaf is below 60 times the volume over the surface area, or 30 times r, which is the radius, times h, which is the height, over the radius plus the height. So let's find the baking time for a loaf that is 4 inches long and has a radius of 3 inches. And we're going to round to the nearest minute of baking time. So let's plug in those numbers, and we're going to get a really quick answer of 51 minutes, approximately, because I rounded. Alright? So, pretty easy for this one. You just plug in the numbers, either the radius and the height, for a cylindrical loaf, and then just plug it in and do some math. Remember to simplify the numerator, then simplify the denominator, then divide. And then you've got your answer. Alright, last one. We're going to take the ratio, and it's not really below, it's just to the right, 60 times the volume over the surface area for a cylinder, and we're going to use the actual formulas for 60 times the volume being pi r squared times height of a cylinder, divided by the surface area of a cylinder, which is 2 pi r squared plus 2 pi r h. Alright, and we're going to simplify the blue one, which is the second one, so that we can figure out that it actually does equal the top one. Alright, so here's the equation. We're going to factor, pull out a 2 pi r, and we're left with r plus h. And we're going to cancel some stuff out from the top and the bottom. The 2's, the pi's, and the r's cancel out, leaving me, or one of the r's cancels out, leaving me 30 times rh, which is what I've got on the top, and r plus h, which is the surface area and the volume. And it basically goes back to the equation on this page, which was right here. See? Look familiar? I thought so. Right there. Alright guys, I'm done talking. Hope you have a good break, because the first time I'm recording this was right after spring break. Alright, bye guys.